Endochondral ossification is the bone formation using a hyaline cartilage model. This form of ossification begins in the developing fetus and continues on in different degrees until the start of adulthood. Endo means inside, chondral means cartilage. Most bones, aside from flat bones, are formed this way. Flat bones are formed via intramembranous ossification, which occurs using mesenchymal cells inside the embryonic fibrous connective tissue. Intra is within, membranous is membrane, within membrane. In endochondral ossification, mesenchymal cells become chondroblasts that secrete matrix and eventually become chondrocytes trapped in the matrix and lacunae as the hyaline cartilage model is formed. The model is surrounded by a perichondrium, which is rich with nutrients. In the center of the cartilage model, chondrocytes enlarge and begin to absorb the cartilage matrix. As the matrix calcifies, this causes the chondrocytes to die, and since the nutrients from the perichondrium cannot diffuse to the now calcified matrix. Stem cells from within the perichondrium divide to form osteoblasts and to form the compact bone collar around the calcified cartilage shaft. A periosteal bud full of capillaries and osteoblasts enter the core of the calcified shaft, forming a primary ossification center. This builds bone using the remaining cartilage as a template, spreading out from the center. As it grows towards the epiphysis, osteoclasts break down some of the spongy bone to form the medullary cavity. Around the time that birth occurs, a secondary ossification center occurs to do the same thing as the primary ossification center, only in the epiphysis, replacing cartilage with spongy bone. Not all of the cartilage is replaced. There is still cartilage in the articular cartilage and in the epiphyseal plate. In the epiphyseal plate, there are 4 zones. The first zone is a zone of resting cartilage, which does not participate in bone growth. Instead, the primary function is to anchor the plate to the epiphysis. In the zone of proliferative cartilage, here interstitial growth, aka growth in length, occurs and the chondrocytes divide rapidly, stacking like coins. In the zone of hypertrophic cartilage, the chondrocytes become larger and form columns. In the zone of calcified cartilage, there are only a few chondrocytes and the matrix is mostly calcified. Osteoclasts dissolve the cartilage matrix so the osteoblasts and capillaries from the diaphysis can come in, and the osteoblasts can replace the ossified cartilage with bone matrix, making new diaphysis and lengthening the bone. The epiphyseal plate basically maintains the same thickness until closer to adulthood, when the plate thins down to a line and eventually is pretty much ossified and growth in length stops. My peer reviewer is Montana.